Happy day everyone. In this video we are going to derive the bandwidth response of feedback amplifier. In the previous part 7 video I have given a broad introduction about feedback amplifier, why we are going for feedback amplifier, and we have calculated the gain of feedback amplifier. Using that gain equation we are going to analyze bandwidth response of feedback amplifier. First of all, why we are going to analyze the bandwidth response of feedback amplifier. Each and every amplifier will process the certain set of frequency. So we are going to design an amplifier, means we should know which set of frequency the particular amplifier will process or the particular amplifier will amplify. For that we are in need of calculating the bandwidth response of an feedback amplifier. For that purpose we are going to analyze the bandwidth response of feedback amplifier. To calculate the bandwidth, we have to know the upper cutoff frequency and the lower cutoff frequency. The bandwidth is nothing but it is the difference between upper cutoff frequency and lower cutoff frequency. So that we have to calculate upper cutoff frequency as well as lower cutoff frequency. Just we can recall the gain equation which was derived in the previous video. The gain of an amplifier AF is equal to A divided by 1 plus beta A. This equation was derived in the previous video. Consider this equation as equation number 1. Using this equation we can rename the equation for mid frequency, low frequency and high frequency, just like this. AF mid is equal to A mid divided by 1 plus beta A mid, which is nothing but the feedback gain in mid frequency equal to the open loop gain A mid divided by 1 plus beta A mid. This is also for mid frequency. Same way we can write for low frequency. AF low is equal to A low divided by 1 plus beta A low. Same way AF high is equal to A high divided by 1 plus beta A high. Consider these three equations as equation number 2, equation number 3 and equation number 4. This is the preliminary consideration we are taking for calculating the bandwidth analysis. First we have to find lower cutoff frequency to find the bandwidth of an amplifier. Before finding the lower cutoff frequency for feedback amplifier, we have to know the relation equation of gain without feedback amplifier. For that equation is, this is the relation equation of gain without feedback amplifier. That's why we are not putting F here. The equation we can rewrite: A low is equal to A mid divided by 1 minus J into FL divided by F. Consider this equation as equation number 5. From equation 3 we know that AF low is equal to A low divided by 1 plus beta into A low. This is equation 3. Just we are substituting this equation 5 in equation 3. The equation becomes AF low is equal to, instead of A low we have to put A mid divided by 1 minus J into FL divided by F. In denominator also there is a term A low, 1 plus beta into, instead of A low again we have to put A mid divided by 1 minus J into FL divided by F. Now we are going to take LCM for this equation to simplification. AF low is equal to, numerator we can write the same term, A mid divided by 1 minus J into FL divided by F. In denominator, by taking LCM, the equation becomes 1 minus j into FL divided by F. Just we are cross multiplying the value, plus beta into A mid divided by 1 minus j into FL divided by F. Now we can cancel this value and this value. The simplified equation becomes AF low is equal to, in numerator, A mid divided by, in denominator we can separate the real term as well as imaginary term. Here the real term is 1 plus beta A mid, and the imaginary term is minus j into FL divided by F. Just we have separated the real term and the imaginary term. For further simplification, we are going to divide numerator and denominator by 1 plus beta A mid. The equation becomes AF low is equal to A mid divided by 1 plus beta A mid, the whole divided by dividing the numerator, this term becomes 1, it will get cancelled, and 1 minus j divided by FL divided by 1 plus beta A mid into F. In this equation, we know that A mid divided by 1 plus beta A mid is equal to AF mid by equation 2. From equation 2, we can write AF low is equal to, instead of A mid divided by 1 plus beta A mid, we can write AF mid divided by 1 minus j into FL divided by 1 plus beta A mid into F. Consider this equation as equation number 7. Now we are going to compare this equation with equation number 6, the relation equation. This equation is the gain with feedback at lower cutoff frequency. This equation is the gain without feedback at lower cutoff frequency. That's why we are not putting F here, and this equation there is F. By comparing the above two equations, we can say there is one extra equation here. We can write separately F, L, F. There is the lower cutoff frequency for feedback amplifier. FLF is equal to, the extra equation we can say F, L divided by 1 plus beta A mid. This is the lower cutoff frequency without feedback, and this is the lower cutoff frequency with feedback. Lower cutoff frequency with feedback is equal to lower cutoff frequency without feedback divided by one extra term, that is 1 plus beta A mid. That's why we are writing the equation separately, and we found lower cutoff frequency for feedback amplifier. Consider this equation as equation number 8. To find the upper cutoff frequency of an amplifier, as similar to the lower cutoff frequency, we have to write the relation equation. This is the relation equation between gain at high frequency and gain at mid frequency for gain without feedback amplifier. Consider this equation as equation number 7. Now we are going to substitute this equation 7 in equation number 4. Equation 4 is AF high is equal to A high divided by 1 plus beta A high. Just we are substituting this equation in this equation. In this equation we can write A high. We are going to substitute A high here. AF high is equal to A mid divided by 1 minus j into f divided by fh. In numerator we have substituted. In denominator also we are having a high. Instead of a high we have to substitute equation number 7. 1 plus beta into a mid divided by 1 minus j into f divided by fh. Now as usual we have to take LCM. I is equal to a mid divided by 1 minus j into f divided by fh. Numerator we have to write the same. In denominator 1 minus j into f divided by fh plus beta into a mid. The LCM is 1 minus j into f divided by fh. Now we can cancel this value and this value. Now the simplified equation is AF high is equal to A mid divided by, we can write the real term separately and imaginary term separately. 1 plus beta A mid, this is the real term, and imaginary term 1 minus j into f divided by fh. Now for further simplification we have to divide numerator and denominator by 1 plus beta A mid. While dividing, the equation will becomes like this: AF high is equal to A mid divided by 1 plus beta A mid divided by this 1 plus A beta mid will get cancelled. It will become 1 minus j into f divided by fh into 1 plus beta A mid. Consider this equation as equation number 8. Now we are going to compare the above equation with equation number 7. I am going to rewrite the equation 7. See, by comparing these two equations, A mid divided by 1 plus beta A mid is equal to AF mid. We know that AF mid is equal to A mid divided by 1 plus beta A mid. So this value will become AF mid. This equation is for gain with feedback and this equation is for gain without feedback. By comparing these two equations, we can say what is the difference. Instead of FH, we are having FH into 1 plus beta A mid. So we can write the equation FH is equal to FH into 1 plus beta A mid. This is the upper cutoff frequency for feedback amplifier. This is the upper cutoff frequency for feedback amplifier. This F represents the feedback amplifier. This is the amplifier without feedback. So there is no F here. So this is the upper cutoff frequency equation for feedback amplifier. So we are adding one F here. This is the upper cutoff frequency for feedback amplifier is equal to the cutoff frequency without feedback into 1 plus beta A mid. By comparing this equation, these two equations, we got this value. This is the upper cutoff frequency for feedback amplifier. Consider this equation as equation number 9. Now we have derived the lower cutoff frequency value and upper cutoff frequency value. By using these two values, we can find the bandwidth of the amplifier. We can rewrite the equation: lower cutoff frequency F is equal to FL divided by 1 plus beta A mid. This is the lower cutoff frequency, and upper cutoff frequency we found FHF is equal to FH into 1 plus beta A mid. So bandwidth is equal to upper cutoff frequency minus lower cutoff frequency. By seeing this equation itself, we can conclude that this bandwidth response is better than the bandwidth without feedback amplifier. This is the upper cutoff frequency and this is the lower cutoff frequency. The upper cutoff frequency is in multiple factor. It is increased further than the cutoff frequency without feedback. In the lower cutoff frequency, it is in a division form. It is reduced than the lower cutoff frequency. So the overall bandwidth response is higher while comparing the bandwidth response of amplifier without feedback. Now let us see the same equation in the graphical model, then you will get the clear picture. See, this is the frequency response graph of amplifier without feedback and this is the frequency response graph of amplifier with feedback. Here the lower cutoff frequency is furthermore reduced according to the equation, and here the cutoff frequency is furthermore increased. So the bandwidth response is higher in the feedback amplifier. That's all about bandwidth analysis of feedback amplifier. From this equation and from this graph, we can conclude that the bandwidth response of feedback amplifier is higher and larger than the frequency response of amplifier without feedback. In the upcoming videos, we can see the topologies of feedback amplifier. Thank you.
Achariya, world-class education.